Hello guys, welcome back to Maison African Motives. Still working on our mathematics N5. We shall be focusing on our partial fractions, which is the part that we shall be working on, dealing or working with integration, but we need to work on the basics of our partial fractions. What is it that we are actually referring to from our partial fractions? Let us consider a condition that we have normally on our fractions in this case. All right, so I'm just going to take from a normal consideration that we have. If we are to deal with a fraction, let's say we are asked to combine 8 over x minus 4 minus 6 over x minus 3 in this case. It's a condition that you are given to simplify from our normal algebraic fractions. We are supposed to combine this and obtain a single fraction. Let us just say we obtained something like 2x over x minus 3 into x minus 4. From our normal simplification, I'm not going to talk about the normal simplification. I'm just saying what is supposed to happen. It is you who are simplifying this whole fraction that we have here to give us this single fraction that we have here. So the partial fraction now is the reverse of now from this fraction to this part that we are separating our fractions into two. So as we can see that from the two denominators that we have got two fractions in this case. These are the same denominators that we have in this case, x minus 3 and x minus 4, x minus 3 and x minus 4. So it follows that what we need is to consider the type of fractions that we are going to have from our simplification. When I'm saying the type of fraction, I'm saying we can be given a condition whereby we are given different, let us consider the first part, given different factors, all right? Given different factors in the denominator. So what we are going to consider in this case is the denominator. In this case, we are going to be working or to be focusing on the denominator to say there are different factors. Maybe we have got three expressions, meaning to say if we have got another bracket here, meaning to say we're going to have another expression there. If we have another bracket, we're going to have another expression. So the number of brackets that we have in the denominator is the one that is going to determine how many expressions are we going to have. That is where we are saying given different factors in the denominator. The denominator is supposed to factorize in this case. So let's say we are given a condition of a certain expression. You can take any number or any function that we want. All right. So given a function of f of x, in this case, we've got function of f of x into x plus or minus a into x plus or minus b, whereby we are dealing with the linear. So these are referred to as linear factors. We are dealing with what? Linear factors. So in order for you to obtain the linear factors, it means the denominator must factorize, okay? The denominator in this case must factorize. Denominator must factorize in this case. So meaning to say, if we are given a condition that we can be able to factorize our denominator, whether there are three brackets or how many brackets that are going to be there, we are going to separate this into a over the first linear expression, the first linear factor, which is the bracket that we have of x plus or minus a plus b over x plus or minus c in this case. So depending with what, if you are given another part, maybe it's a c x plus or minus, it's gonna depend with what you have. Okay, so here we are having a b. Remember, this is a b, so this is gonna be a c, and so on and so on, depending with the number of expressions, the number of brackets that are in the denominator here. How many factors are you having in the denominator? That is the one that you're going to consider. So you have separated. So what you're going to do is to find the values of a and b. By finding the values of a and b, we have expressed our function into two fractions. That is, partially we have separated our fraction. That is the opposite, the vice versa of this part. from a single fraction to a condition whereby we have two fractions. Before, you were asked to simplify this into a single fraction. Now you want to separate that single fraction into two. So you want to check how are they going to ask these typical questions, but that is the idea that you're going to have as long you are dealing with the linear factors whereby the denominator, the factors in the denominator are different. That is the condition. Like, for example, we're asked to express this into partial fractions. We are given 2x over x minus. We want to play with that part that we had before and see if we are going to obtain the same answer. We want to express this into partial fractions. So as you can see, we said the denominator already, we've got two factors in this case in the denominator, and they are linear factors. We're going to have a over this. So this is going to give us a over the first factor, which is x minus 3 plus b over the second factor, which is x minus 4. So what we need in this case is to find the value of what? The value of x, the value of a and b. If you were to consider adding this part as an equation, we are going to say this numerator of 2x, it is going to be equal to, so we shall consider our numerator in this case of 2x being equal to. So what you do is that remember, on your normal simplification, you were supposed to find the LCM. This is what you're supposed to do. You're supposed to find the LCM of these two. You're supposed to find LCM, which is x minus 3 into x minus 4. Then you divide x minus 3 and x minus 3 cancel. You remain with x minus 4. So it's going to be a times x minus 4 plus you do the same thing, x minus 4 and x minus 4 cancel. You remain with b into x minus 3. This is what you're supposed to have, and you equate this. Instead of you now adding this part back to obtaining a single fraction, this is, you use the idea that you have here to say, if you are to take a, this is the same LCM that we have here, which is the LCM of x minus 3. So you simply divide the x minus 3 and the x minus 3. You remain with what? You remain with x minus 4. So it's going to be a into x minus 4, which is the same part as what we can see here. The same thing for this b, we are going to have plus b times x minus 4 and x minus 4 here cancels. You remain with what? You will remain with x minus 3, which is the same part as what we have here. But it's going to be a waste of time for us to simplify this into a single fraction. Just from this step, equate this part. Then at this stage, you are supposed to find now the values of a and b. That's where you ask yourself, how can you find a and b? How can you eliminate? How can you remove because these are factors. So we can get rid of this part and remain with the part of this part. How can we do that? We work with the bracket that is affecting. We equate this bracket simply to 0. If we say, let the bracket of x minus 4 be equal to 0, it means this whole part is going to give us a 0. So by doing this, we can find the value of x to say x is equal to 4 in this case, minus 4 to the other side. So meaning to say, if our x is 4 here, and we substitute 4 minus 4 is going to give us a 0, and this whole part is no longer there. We have eliminated this part. So meaning to say, we are going to say when x is equal to 4, what are we going to have? Substitute 4, where there is an x in this case. So this is going to be 2 times 4 in this case, all right? So this one is 2 times 4, which is equal to, here we have substituted 4. So 4 minus 4, that's a 0. So meaning to say this whole part here is going to give us a 0. We substitute a 4 here, 4 minus 3, we are going to obtain a 1. 1 times b, which is b. So meaning to say 8 is going to be equal to b. So we have obtained the value of b from what? From x being equal to 4. We eliminated the bracket, the first bracket. We are going to do the same thing on the bracket of x minus 3. We simply let this bracket to be equal to 0. So if x minus 3 is equal to 0, it means x at that moment will be equal to 3. So now it's a condition that you can consider. When x is equal to 3, what is going to happen? You have to substitute 3 here, you have to substitute 3 here, you have to substitute 3 here. So what are you going to have at the end? We are going to see that here we are going to have 2 times 3, which is 6, is equal to, here we subtract 3 minus 4. That is going to be negative 1. So it's going to be negative 1 times a, which is negative a. 3 minus 3, that's a 0. We no longer have anything here because 0 times b, we are going to obtain a 0 there. So divide by negative 1. By negative 1, we have the value of a. So a is going to give us a negative 6 in this case. All right. With the value of a, and the value of minus b, we are going to substitute back these values now to represent our expression, the one that we have here. So meaning to say this whole part at the end is going to give us what? All right, let's conclude to say, therefore, we are going to have the expression of 2x over x minus 3 into x minus 4, this whole part here being equal to a over x minus 3, and our a is -6. So it's going to be -6 over x minus 3. So we are going to have x minus 3 plus b, our b being 8. So it's going to be plus 8 over x minus 4 in this case. All right, so this is what we are going to have at the end as separated. Now we have got two fractions that are separated from the normal f of x that we had before, a single fraction. Now it's separated to two fractions. That is the idea. So on our integration part, you'll be given such a condition like what we have. They will ask you now to integrate. If the question was to ask us, in this case, if we are being asked to integrate this part that we have here, let us just conclude with our integration. If the question was now integrate 2x over x minus 3, we are asked to integrate this part here with respect to x. What does it mean? You can see that, okay, this is a complicated situation to work with. So you express into partial fractions. That's where you obtain these two fractions that you obtain. So meaning to say this whole integral is the same as the integral of this part that we got, because this part, these two are equal, are the same. So we are going to have the integral of this whole situation that we have here, which is -6 over x minus 3 plus 8 over x minus 4 with respect to x. That is the same thing that we have here, but we have expressed into a situation that we can be able to integrate. That is where our integration is playing a role now. So from our integration, if we are to integrate -6 over x minus 3, we know that it's a ln. So find the derivative of x here, that's a 1. So you're going to have -6, the ln of x minus 3. All right, 8 over x minus 4 is going to be 8, the ln of x minus 4 plus the constant of our integration. We're done. So that is the idea now that you are going to have when you are now integrating. You'll be given to integrate this part with respect to x. But because you can't integrate it direct, you express it into partial fraction, and they'll actually ask you x by expressing into partial fractions, or integrate this by expressing into partial fractions. So that is what we are going to have in our condition. So let us consider, for an example, maybe you are asked to integrate with respect to x. All right, let me try to decrease a little bit here. All right, so like I'm saying, we want to consider a question whereby we are asked to integrate with respect to x. So let's take, for an example, we are given 4x in this case over the expression of 1 minus x into 3 minus x, like this. All right, we are asked to integrate this with respect to x. So the idea is first express into partial fractions, all right, into fractions that you understand. So here we are going to express into partial fractions. That means we are going to have 4x over 1 minus x into 3 minus x. These are linear factors. They are already in the linear form. So we are going to have a over the first bracket in this case, which is 1 minus x, plus b over the second bracket, which is 3 minus x. So remember what I said, instead of you having a single fraction, just take the numerator from what we have on the left-hand side. So 4x is equal to a into, you divide 1 minus x, and 1 minus x cancels. You remain with what? You remain with the 3 minus x, plus you do the same thing for b. The 3 minus x and the 3 minus x will cancel. You remain with the 1 minus x. So from these brackets now, that's where you are supposed to find the value of a and b using the condition that we talked about, saying we are going to let this bracket be equal to 0. We also let this bracket to be equal to 0. So let us start with the first bracket. If we are to let 3 minus x to be equal to 0, it means x at that moment must be equal to what? 3. That is for this bracket to give us a 0, x must be equal to 3. So that is what you're going to have when x is equal to 3. That means in place of x here, we substitute a 3. Where there is x, you're going to have a 3. So you're going to have 4 times 3, which is going to be 12, is equal to, here we have a 3. So 3 minus 3, that's a 0. We put a 3 here in place of x, so it's going to be 1 minus 3. 1 minus 3, which is going to give us negative 2. So we are going to have negative 2b in this case. So take note, this whole part, it gave us a 0. 0 times a is going to give us a 0. So that is the idea that you're going to have. So this is a condition when our x is equal to 3. So you can divide by negative 6, by negative 2 both sides in this case, so that you obtain the value of b. So our b is going to be 12 divided by negative 2, which is negative 6. So we have the value of b in this case. So from this part, what you're going to do is to go back to the other bracket. Ask yourself, how can you let this bracket to be equal to 0, this whole bracket, where we have got what? Where we have got a 3 in this case. So what are we going to do? That is the question. All right, so from this part here, we can simply say, let this bracket, sorry for this, let the bracket of 1 minus x be equal to 0. That means 1 is equal to x. So if x is equal to 1, this bracket is going to give us a 0. So that means that is what you're going to put into consideration to say when x is equal to 1, in place of x, you're going to substitute a 1. So 4 is equal to, in place of x, you're going to substitute a 1. So it's 3 minus a 1, which is 2. So it's going to be a times 2, which is 2a. Where there's x, we substitute 1. 1 minus 1, that's a 0. So this part is going to give us 0 times b, which is b. Divided by 2 by 2, that we have the value of a, which is going to give us a 2. So from this condition, our a is giving us a 2. But this is not our question. This is not our question was to integrate this part with respect to x. So what are we going to do? We are going to take the final part now to say, okay, what we obtained here simply means that, all right, let's substitute first. Let's substitute. I don't want to confuse you. We have got our a over 1 minus x. This is what we have, a over 1 minus x. So we're going to have our a, which is 2. So we're going to have 2 over 1 minus x plus b, our b being a negative 6. So take note, this is plus b, and this is going to give us a negative 6 in this case. All right, so that is going to be a negative 6 over 3 minus x. All right, so with this consideration that we have now, with this condition that we have, we are supposed to integrate, because this part here is representing what we had before, which is the 4x. This is representing the 4x over 1 minus x. That's 1 minus x into 3 minus x. This is what is representing our fraction. But the question was for us to integrate. So we are going back here to say the integral of this whole part that we had, which is represented now by what? It is represented now by this fraction here, this part here that we have, which are these two fractions. So that means we are going to have this as the integral of 2 over 1 minus x minus 6 over 3 minus x. So this is what we are going to have with respect to x. So take note, if you are integrating a function, we are supposed to have ln, but take note, we are supposed to obtain, let us just say we have got k over f of x in this case, which is x, let us just say ax plus b, so that you can understand. It's a linear expression that you're going to have. You are integrating this with respect to x. So it is going to be k over a, the ln of ax plus b. Take note, k over a, which is the derivative of f of x, this part that is containing x, you find its derivative. So in this part, we're going to obtain 2 over the derivative of minus x, which is the part that is affecting x, the coefficient of x there, it's -1. So it was supposed to be 2 over -1, the ln of 1 minus x, minus 6 here over the coefficient of x there, which is -1. So it's supposed to be -1, the ln of 3 minus x plus the constant of integration. Please take note. So at the end, we're going to have -2 ln of 1 minus x, then here negative and negative, that's going to be a positive 6, the ln of 3 minus x plus what? Plus the constant of integration in this case. So that was the whole idea there, the whole idea. Be careful also on your integrals there. How are you going to work with your integral? A normal integral, how are you going to play around with it? So these are not only questions that you might have. Sometimes they might give, and even if the denominator is not factorized, it asks the idea is supposed to be the same, the integral of 6x plus 12 everything over x squared plus 5x plus 6. Then you might wonder, what is it that am I supposed to do? We are not having factors in the denominator here. So what are we supposed to do? We are supposed to factorize first the denominator. So consider to factorize the denominator. Like I said, the denominator is supposed to factorize. All right, that is, we are supposed to factorize first. So if we are to consider, we've got x squared plus 5x plus 6. Are we going to factor out this? Do we have factors in this case? All right, so let us consider two brackets. Since the coefficient of x squared here, it's a 1. So we are going to have the coefficient of x squared, it's a 1, and we've got x squared, so we're going to have x and x. So ask yourself, what are the factors of 6? And these factors of 6 should add up to 5. So we've got 3 and 2 in this case, or 2 and 3. So these are the factors, 3 and a 2. So that means this whole part, or this whole integral that you're given, it was supposed to be given as 6x plus 12 in this case over x plus 3 into x plus 2 like this with respect to x. And also this question, if you are to check here, it's only that we are working with partial fractions, but here we are not even supposed to use partial fractions, because check what is happening in the numerator. It is, we have got 6x. If we factor out here, 6 is common here. If we factor out 6, we are going to remain 6x divided by 6, it's x. 12 divided by 6, it's 2, like this, over x plus 3 into x plus 2, like this. We're not even supposed to factor, because here, this one and this one was going to cancel, which means we're just going to remain with the 6 over x plus 3. We integrate this, which was going to give us 6 ln of x plus 3 plus the cost of integration. So this one, we're not even supposed to use partial fractions, but we want to apply this under partial fraction and see if we are going to have the same answer. So let's see. We have the answer there. We want to see if we are going to have the same answer like this. Remember, from our partial fraction state, we are going to express this into partial fractions, 6x plus 12 over x plus 3 into x plus 2, which is going to be, we've got linear factors, so it's going to be a over the first factor, x plus 3, plus b over the second factor, which is x plus 2. From this concept, I said we are just going to equate from the numerator, our numerator, which is 6x plus 12 is equal to a into x plus 3, and x plus 3 was going to cancel. You remain with the x plus 2 plus b into the x plus 2, and x plus 2 was going to cancel. You remain with x plus 3 like this. So that was the condition of your question. And in this case, you equate each bracket to 0. So here, in order for us to get a 0, our x was going to be a -2. When x is -2, you substitute -2 here. What were you going to obtain this side? -12 plus 12, that's a 0 in this case. And here we've got -2 plus 3, which is going to give us a +1. So 1 times b, that's b. b is equal to 0. Take note what happened there. We move on to this bracket. For this bracket to be equal to 0, x was supposed to be a -3. We substitute x being -3 here, 6 by -3 by plus 12. This was going to give us -6. When x is -3 here, got -3 plus 2, which was going to give us -1 times b times a, which is -a divided by -a was going to give us a +6. All right. So this is what we're supposed to have. Meaning to say here, we're going to have at the end 6 over x plus 3 plus b, our b, which is a 0. So it's going to be 0 over x plus 2. 0 over x plus 2 means there's nothing here. There's nothing. So meaning to say this whole part, we're going to just remain with this part, which is the integral of 6 over x plus 3 in this case. Sorry for this. with respect to x, as we saw that the other part is giving us a 0. So that is the condition. So like I said, this one we're not even supposed to use by parts, but by partial fractions. But in a condition that they are saying use partial fraction, there is no way. So you integrate this, we're going to have 6 ln of x plus 3. Remember, the derivative of x is 1, so it was supposed to be 6 over 1 like this. But 6 over 1 is going to give us what? It's going to give us a 6. So that means this part is not even important. So we are going to have 6 ln of x plus 3 plus the cost of integration, which is the same answer as the one that we got in this first place, the one that we did not even apply our partial fractions in this case. So these are the typical questions that you might have. So sometimes we might not be given a condition like this. We might be given a condition of recurring factors. What are recurring factors? That is the question whereby you can be dealing with recurring factors. These are the factors that are keeping on repeating, whereby we are given a condition of, let's just say we are asked to integrate 9x plus 25, everything over x plus 3 squared like this, or let us just squared with respect to x. So it means we've got the bracket of x plus 3. It's repeating. It can be up to the exponent of 3. So what you are simply going to do is that you take each part. You're going to start with x plus 3. If it was to the exponent of 3, we increase our exponent up to the last exponent that you're given, starting from 1. So meaning to say this whole part, it was going to be 9x plus 25. Let me explain this by writing what I'm trying to say. X plus 3 to the exponent of 2. This was going to be a over the first part bracket of x plus 3, plus we move on to the exponent of 2, b x plus 3 to the exponent of 2. If this was to the exponent of 3, let's say it was to the exponent of 3, we were going to have another part here, plus, again, we're going to have plus c over x plus 3 to the exponent of 3. So we raise this up to the last exponent, that we up to the number that we have, or the highest exponent. That is the idea there. But as you can see, once you have this, the idea does not even change of expressing into partial fractions. So we shall have the first term, our just equate the numerator there as it is 9x plus 25 is equal to, like I said, we're going to have a, we divide. So there are 2 brackets here of x plus 3. So if we divide this bracket into 2 of these ones, we are going to remain with the 1 x plus 3. Here we are going to have plus b. We divide, there are 2 here, there are 2, they cancel each other. So when you say we're supposed to remain with a 1, which is same as what? Which is same as we've got a b in this case. So we can consider this bracket when x is equal to what? Minus 3 here, because if we say x plus 3 is equal to 0, x is going to give us minus 3. So when x is minus 3, we are going to substitute minus 3. Wherever there is x, we are going to substitute what? Negative 3 when x is equal to negative 3. So meaning to say, this part is going to give us a negative 2. We are going to have negative 2 is equal to cancel here. We're going to have a b. So on this part is direct. So the next stage is either you're going to expand, or you can choose any number of your choice, because we have the value of b. So you can even choose to let x be equal to 0, or you can expand the brackets and equate the coefficients, so that because we do not have the part that we can equate to say let x be, unless you can choose let x be equal to 0 if you want, or you can simply what? Expand the brackets here. That is going to be 9x plus 25 is equal to expand a times x. We are going to have a times 3, which is going to give us 3a plus b. After expanding, equate the coefficients of x, because you want to calculate a. And we can see that here we've got a on the coefficient of x. We've got the coefficient of x, and by equating the coefficient of x, we can, this is the only x that we have this side. This is the only x that we have this side. So it means our a is supposed to be equal to what? To 9. By equating the coefficient of what? The coefficient of x. We are dealing with the coefficients, in this case, the coefficient of x, that is the number that is affecting x at that moment. So this is what we are going to remain with at the end. As you can see, we have the value of b and we have the value of a. So we can substitute back into our part here that we have a over this, or we can just substitute direct to our integral. So at the end, this was going to give us the integral of a over x plus 3, of which our a there is 9. So it was going to be 9 over x plus 3 plus b. Our b is -2. So it was going to be -2 over x plus 3 squared. So this is what we are supposed to end up with at the end. And we are supposed to integrate this with respect to x. This is the same integral as this part that we're given before. So if it is the same integral as this one that we're given before, we are simply going to integrate this part with respect to x. All right, so let us try to integrate and see what we are going to have. How are you going to integrate this part? That is the question. How are you going to integrate this part with respect to x? How are we going to integrate this? All right. So considering this part, the first part is direct, like I said. We are just going to have the derivative of this, which is 1. So it's going to be 9 over 1, which is simply 9. So it's going to be 9 ln x plus 3. All right. Minus, we're supposed to integrate this part of -2. Let us just consider this aside, the integral of 2 over x plus 3 squared. All right. How can we integrate this? It differs with which idea are you going to use. You can even use substitution method, where we can choose to let u to be equal to x plus 3. So if u is equal to x plus 3, we have to find du in this case in place of dx in place of du. So you're going to have du dx, which is equal to 1 here, and this one is a 0. So if we cross multiply, it means our du is equal to dx. Where there is dx, same as there is a du. So we are going to end up having the integral of 2 over, remember, this is now represented with u, so that's u to the exponent of 2 du in place of dx, of which this is same as 2u to the exponent of -2, so that we can properly integrate. Remember, integral, we add 1. So we are going to add 1, which is going to give us what? A -1. So it's 2u to the exponent. All right, so this one was going to give us 2u to the exponent of -1 over -1, which is going to give us at the end -2u to the exponent of -1, which is -2 over u. But our u in this case is what? It's x plus 3. So it's going to be -2 over x plus 3. Remember your integration by substitution method. So meaning to say, at the end, from this whole integral that we see here, we're going to obtain -2 over x plus 3 in this case. All right, plus the constant of what? Of integration. So that is what we were going to have at the end. And with this part that we have, we can just simplify. That is going to be 9 ln of x plus 3. Negative and negative is going to give us a positive. So we're going to have 2 over x plus 3 plus the constant of integration in this case. So these are the typical questions, like I said, that you might be given, and you just need to play around with. Sometimes it's not like you're going to be given the denominator that just factorizes. Yes, it might factorize, but if you are given a consideration that the exponent of the numerator and of the denominator are the same, or you are given a condition that you might be given a condition whereby the numerator is having a higher degree or a bigger degree, or they are of the same degree with the denominator. In that condition, you are supposed to apply the long division first. If the numerator is having the same degree or higher degree than what? The denominator, like here, the highest exponent is 2, the highest exponent is 2. They have the same degree. So you apply the long division first. So we are going to apply long division first in this case, so that we obtain a proper fraction. This one is called an improper fraction. So if we divide, we are going to divide, that's x squared minus 1 into x squared into this into x squared. All right, so let's divide. That's going to be x squared, remember, divided to x squared, which is going to give us 1 from our long division concept. So this 1 is going to multiply back everything that we have. Yes, 1 times x squared, which is going to be x squared, 1 times minus 1, which is minus 1. Then we subtract. All right, so if we subtract, is x squared minus x squared, that's a 0. Here it's same as we have got a 0 there, so it's a 0 minus minus 1. So 0 minus minus is going to be a plus, which is we are going to have a 1. And we can't divide 1 divided by x squared. It's impossible. So this is our remainder. So this is showing that we have got what? We have got a remainder there. So meaning say this whole expression after dividing, we got a single term, which is 1. After dividing, we got a single term, which is 1, plus the remainder, our remainder, which is 1 over what? This whole expression that was dividing, which is x squared minus 1. So it's the part that we got the exact term plus the remainder over what was dividing. So this is what we are supposed to integrate with respect to x. But as we can see under this integral that we have, we can see that still this can be expressed now into partial fraction. This one is a simpler term. The exponent, the numerator is of lesser degree than the denominator. So it means we can express this into partial fractions now, which is the remainder part. So this part expressed into partial fractions, it is going to give us what? This is going to be 1 over x squared minus 1. That's a difference of 2 squares. So we're going to have x minus 1 into x plus 1. So this is going to give us a, these are linear factors. So it's a into x minus 1 plus b into x plus 1. They are different factors. So we can find a and b. Remember the concept, 1 is equal to the numerator here, which is a into x minus 1 cancels. You remain with what? With x plus 1 plus b into x plus 1 cancels. You remain with x minus 1. So in order for us to obtain 0 here, we are going to let x to be equal to minus 1. So when x is equal to -1, that's going to give us a 0 here. So that means we have 1 is equal to, here we are going to have -1. So it's -1, which is -2b. Divide by -2, our b is going to be -1 over 2. We do the same concept or the same thing on this bracket. For this bracket to be equal to 0, x must be equal to 1. So when x is equal to 1, that means here there's nothing that we are going to substitute. So we have 1 is equal to 1 plus 1, that's a 2. So we're going to have 2a. This part is given, we have a 0 there. So we're going to divide in order for us to have the value of what? The value of a, which is our a is going to be 1 over 2. So that's here. We've got our a being 1 over 2, our b being, so this is what we are going to substitute here to say the whole integral is going to be 1 plus this part expressed in partial fractions, which is supposed to give us what? A over x minus 1, and our a is 1 over 2. So it was going to be like this, 1 over 2. But we can't write 1 over 2 on top like that. We write it as 1 over 2 like this in this bracket. So it is going to be 1 over 2 into x minus 1 plus b, our b, which is minus half. So it is going to be minus half, which is minus 1 over 2 into x plus 1. So this is the whole part that we're going to have to remain with. After expressing this, you express the remainder part into partial fractions. From there, we can be able to integrate each part. As we said, once we are dealing with this part, we are just going to integrate each and every part. So this is same as we've got 1 over 2. When it's like this, 1 over 2 is not, it's a constant. So you are considering 1 over x minus 1, the integral of this. So meaning to say, let's start with 1. The integral of 1 with respect to x is going to give us x plus, so 1 over 2 is a constant. So we're going to write it as 1 over 2 like this. The integral of 1 over x minus 1, this is the one that gives us what? Ln x minus 1. The integral here, we've got minus half again, which is a constant. We go to the integral of 1 over x plus 1, which is going to give us ln of x plus 1 plus the constant of integration in this case. All right, so that is it. As we can see, guys, it's a matter of working with more questions here. It's a matter of working with more revisions. So let us continue to work with more revisions, more question papers as we are preparing ourselves for the exams that are ahead of time. With this introduction, let us now consider more question papers. We have to work with more question papers. There are a lot of questions that we have. There are a lot of revisions that are similar to what we are talking about now. So you just have to work each and every question paper and see how are they asking a question on partial fractions. If there's a challenge, then it means you do not understand this topic. Recap again, or let us know the questions that are still having a challenge. It can be a question paper from any past a year that was written before. Let us know that question, so that we can work with that question together on this platform. But for now, guys, that's it from Maison African Motives. Till we meet again.